Okay, hello everyone. In this video, we are going to evaluate Laplace transform of some basic functions. Okay, around 16 basic functions are there. So let's start. Okay, so the Laplace transform of a function, any function ft, will be written as this one. Laplace transform. This symbol is this symbol, this type of L, this design of L is considered here Laplace transform. Okay, so Laplace transform of any function is nothing but integration of 0 to infinity e to the power minus st into f of t dt will be equal to, also can be written as, is written as f of s. Okay, some books they are written 0 to infinity e to the minus I omega t into f of t dt, which will be written as capital F of omega. Okay, but here we consider that s. So e to the minus st into f of t dt integration 0 to infinity is nothing but called as your Laplace transform of this function. This also can be written as capital F of s. Okay. Okay, so first we are going to consider our first function as f of t is your 1. Then Laplace transform of ft will be written as, in this format, first I am going to write 0 to infinity e to the power minus st into 1 into dt. Okay, so here integration of e to the minus st dt we are going to be consider. So e to the minus st integration will be e to the minus st by minus s 0 to infinity. You put the upper limit and lower limit. So here infinite means here e to the minus infinite, 0 means e to the 0 by minus s. So here e to the power minus infinity will be 0, e to the 0 is your 1. So minus minus got cancelled, we found 1 by s. Okay, here we found Laplace transform of function 1 is your 1 by s. So here I am going to tell that if I am going to consider inverse Laplace transform of 1 by s, we can found 1. So here I am going to write inverse Laplace like this. Inverse Laplace transform of 1 by s will be equal to 1. Okay, these last expressions you have to remember. Okay, whenever you are going to do the long questions, these last expressions, this value, Laplace inverse Laplace transform of 1 by s will be 1. These values will be required. So next function is our second number function is your ft equal to t. So similarly we have to write 0 to infinity e to the minus st into t dt. Here we are going to consider the by parts. So I let inverse, logarithmic, arithmetic, trigonometric, exponential. So here you can see the arithmetic will be the first function. So t will be there. This one is your exponential. Integration of this one will be e to the minus st by minus s. 0 to infinity will be the limit minus derivative of this one. T will be 1. Integration of e to the minus st is this one. Again another integration will be there, ds. Okay, so here you can see that if I will put infinite, so here you can see e to the minus infinite will be 0. Whenever we are going to put 0, then t is there, means 0. So this term will be 0. Here minus is there, minus plus 1 by s e to the minus st minus st. This is mistakenly written, this is dt. Okay, this is dt. Okay, so 1 by s is there, 0 to infinity e to the minus st dt. So integration of e to the minus st is nothing but e to the minus st by minus s. Already 1 by s is there, and 1 by s e to the power minus st 0 to infinity. I will put the limit, it will be e to the minus infinity minus e to the 0 by minus s. So here it will be 1 by s into this will be 0 minus 1 by minus s. So 1 by s square. Okay, so here we found that Laplace transform of t is 1 by a square. Similarly, we can write inverse Laplace transform of 1 by a square will be equal to t. Okay. Next, we are going to go for the third function, that is your ft equal to t to the power n. Okay. Now, Laplace transform of ft means t to the n will be written as 0 to infinity e to the minus st into t to the n dt. Okay, so This will be written as t to the power n into e to the power minus st dt. So here you can see that this is a gamma function. Okay, this is a gamma function because you just recall or you can follow my short video. You can found this integral that 0 to infinity x to the power n e to the power minus a x to the power m dx is a gamma function. You can follow the short video. Okay, value of this integral is nothing but 1 by m into 1 by a to the power n plus 1 by m into gamma n plus 1 by m, right? So here you can see that if we are going to compare this integral with this integral, both have same format. Here x is there, t is there, to the power n e to the power minus a x to the power m. Here e to the power minus s instead of x, t is there. Okay, you can see if you are going to compare with these two integrals. So here n is same. Okay, here x to the power n, here t to the power n. Okay, e to the power minus st, here s is equivalent to a, and t to the power m, t to the power x to the power m, t to the power m means t to the power 1 is there. Okay, 1. So here we found that n equal to n. Okay, a equal to s and am equal to 1. We are going to substitute these values इन दिस आंसर. ये आंसर में हमको डालना है, क्या क्या मिलता है देखते हैं. तो 1 बाई एम दैट मीन्स 1 बाई 1, 1 बाई 1 इंटू 1 बाय a to the power n plus 1 by m. Here a means s, s to the power n plus 1 by m means 1, 1 into gamma n plus 1 by 1. Okay, so here 1 by 1, 1, 1 by, here you can see s to the power n plus 1 by 1 means s to the power n plus 1, gamma n plus 1 by 1 means gamma n plus 1. Okay, so here we found, and we know that this value is nothing but n factorial. We know that one, gamma n plus 1 is nothing but n factorial. So n plus 1, gamma n plus 1 written as n factorial by s to the power n plus 1. So this is the Laplace transform of t to the power n, right? Likewise, inverse Laplace transform of n factorial by s to the power n plus 1 will be equal to ओरिजिनल फंक्शन e टू पावर n. मैं यहाँ पे क्यों बोल रहा हूँ, डायरेक्ट मैं यहाँ पे बोल देता हूँ कि उसका इन्वर्स ट्रांसफॉर्मेशन क्या होगा. ओके, तुमको याद रखना है बोथ, इसको भी याद रखना है और इसको भी याद रखना है. बोथ हमको चाहिए, जब लॉन्ग क्वेश्चन हम सॉल्व करेंगे बोथ चाहिए. ठीक है, नाउ वी आर गोइंग टू गो फॉर द अनदर फंक्शन इज ए कांस्टेंट k. सी Laplace transform of function ft equal to k, that means Laplace transform k will be direct. I written k by s. Here you can see why I written, you just take common k from outside. This is a constant taken outside. So k Laplace transform of 1, we can write Laplace transform of 1, we found how much, 1 by s. So this value will be k by s, I directly written. So similarly we can write inverse Laplace transform of k by s, inverse Laplace transform of k by s will be equal to that constant k, right? Okay, now we are going to go for the fifth function, that is your ft equal to e to the power at. So Laplace transform of e to the power at will be written as 0 to infinite e to the power at, the function into e to the minus st into dt, and this will be written as the power will be add the 0 to infinity e to the power a minus st dt, right? Here one you can mark one thing, that always we have to write in this type 0 e to the power minus st into this function. Here for this case, here you can see e to the minus st, and here the minus is not there. To do so, what I am going to take, minus taken a common from these two terms, it will be minus s minus a. In this format you have to write minus s minus a t. Here you can write it minus s minus a t. Okay, here e to the minus s minus a t dt. So if I am going to consider the integration of this one, e to the power minus s minus a t dt, this will be e to the minus s minus a t by s minus a minus s minus a minus s minus a minus s minus a. So just put the limit. If I'm going to put infinite, so e to the minus infinite 0 e to the 0 by this will be minus s minus a, just right, minus s minus a, correct it. So we are going to find that this value will be how much? 0. This will be 1. So minus 1 by minus s minus a. Minus s minus a. So minus minus got cancelled. We found Laplace transform of e to the at will be equal to 1 by s minus a. Similarly, here I am going to write that inverse Laplace transform. Inverse Laplace transform of 1 by s minus a, suppose we want to find out, then this value will be e to the power at. Okay, so you have to remember this one and this one also. Laplace transform of e to the power at, 1 by s minus a, and inverse Laplace transform, obviously inverse Laplace transform, if I will apply over this, then it will be e to the power at. Here you can see that, see, in this style, Laplace transform of e to the at is your 1 by s minus a. I am going to apply inverse Laplace transform both the side. So inverse Laplace transform of e to the power at equal to inverse Laplace transform of 1 by s minus a. So here Laplace transform and inverse Laplace transform. That means x into 1 by x will be 1. So this will be cancelled out. We found inverse Laplace transform of 1 by s or function, this type of any function will be equal to this one, only e to the power at. Okay, you have to remember both Laplace transform and its corresponding inverse Laplace transform. Next, we have to go for the sixth number question. Sixth number expression or function, you can say ft equal to sine at. So Laplace transform of sine at will be written as e to the minus st into sine at dt. So here I written directly because last class we have been discussed the integral value of this one, e to the x sine bx will be equal to this much, right? Here I written because e to the x into sine bx dx equal to this much we know. So you just compare this integral with this integral. Here you can see that a is nothing but minus s. Okay, instead of x is t is there, and b is nothing but a. Okay, so in this expression we have to put, instead of b we have to put a value, because b, if I am compare this one, b is a. Instead of b we have to put a. Okay, instead of t, we have to put, sorry, instead of x we have to put t. So here x is there, t, this will be t, and this will be t. Okay, and instead of a we have to put minus s. So this a will be minus s, this will be minus s square, b square. B square means a square. Okay, and here a means minus s, we have to put like this. So if we are going to do so, then the integral value of this one will be, see, e to the power minus st. Here you can see instead of a minus s, e to the power minus st by minus s square plus a square into a means minus s sine at. A means sine at because sine here bx means at. Okay, minus here you can see a cos at. A cos at, limit we have to consider 0 to infinity. Okay, so now first limit infinite, if I am going to put this term will be 0, the entire term will be 0 0. Now we are going to consider the lower limit. Lower limit, if I am going to put over here, this e to the power 0 by this is a square plus a square into here, instead of t, 0 means sine 0 will be 0 minus cos 0 will be 1. So this will be a minus minus plus a by a square plus a square. So Laplace transform of sine at equal to a by a square plus a square. Similarly, we can write if I am going to apply inverse Laplace transform both the side, then we can get inverse Laplace transform of this one. Inverse Laplace transform of a by a square plus a square, s square plus a square equal to sine a t. You have to remember both this one and this one. Okay. See, occasionally तुम्हारे एग्जाम में ये क्वेश्चन पूछा जाएगा 2 मार्क या 3 मार्क के लिए, तो यू हैव टू डिराइव दिस 3 to 4 स्टेप यू हैव टू डिराइव. But for your long question, you need the direct answer of Laplace transform of sin 80. At that time you have to put this value. वहाँ पे तुम डायरेक्ट सब्स्टिट्यूट करना है. मगर अगर 2 मार्क या 3 मार्क क्वेश्चन पूछा जाता है एग्जाम में, तुमको ये 2-3 स्टेप करना पड़ेगा. ठीक है. नेक्स्ट फंक्शन इज योर cos 80. Similarly we have to do cos 80 means e to the minus st cos 80 dt, and we have to follow the another integral, this one e to the x cos x, e to the x cos bx, e to the x by a square plus b square, and this much plus a cos bx plus b sin bx. Okay, see how you are going to remember this. E to the ax by a square plus b square is common for both the integral, but here sin bx means sin bx will be come up, cos bx means cos bx, a is the common, so a sin bx, whenever sin then the another term followed by minus, but cos means another term followed by the plus. So sin means a sin bx minus b cos bx, cos means a cos bx plus b sin bx. Like that you have to remember these two integrals. Now if I am going to write this one, similarly here I written e to the x cos bx is nothing but e to the x by a square plus b square into a cos bx plus b sin bx. So instead of a we have to substitute minus s and instead of t we have to substitute x. Instead of x it will be t, instead of a will be minus s, and instead of b we have to put a. If I am going to do so, then the integral value will be e to the minus st by a square minus a square plus a square whole into minus s cos 80 plus a sin 80. 0 to infinity is the limit. Now you are going to put the infinite, this term will be 0, then entire term will be 0, minus 0 if I am going to put, then e to the 0 is 1, e to the 0 by minus a square is a square plus a square whole into minus s cos 80. Cos 80 means cos 0 plus a sin 0. This term automatically will be 0. Then we found Laplace transform of cos 80 will be equal to, here you can see minus minus plus, this will be 1, s is there, s by a square plus a square. Okay. Likewise, inverse Laplace transform of s by a square plus a square will be equal to cos a t. Right? Have to remember this and this both. Next function is your sin ht. Sin ht. ओके, देखो ये जो 16 फंक्शन को हम 16 फंक्शन का लाप्लास ट्रांसफॉर्म हम निकाल रहे हैं, वो बहुत ही इम्पोर्टेंट है शॉर्ट क्वेश्चन के लिए और तुम्हारे एंट्रेंस एग्जामिनेशन के लिए भी. कभी कभार वो डायरेक्ट तुमको पूछा जाएगा, तो तुमको अगर याद है तुम लिख पाओगे, नहीं तो दिक्कत होगा. ठीक है. सो नेक्स्ट फंक्शन इज योर साइन एच ए टी, 0 to infinity e to the minus st sin h a t dt. So here sin h a t will be written as e to the a t minus e to the minus a t by 2. Okay, dt. So 1 by 2 taken outside, 0 to infinity. Here two integral we can found, e to the minus st into e to the a t minus here e to the minus st into e to the minus a t dt. Right. So two integrals obviously. So 1 by 2 taken outside. This will be one integral, 0 to infinity e to the minus st into e to the a t dt minus e to the power minus st into e to the minus a t dt. Right. Now here you can see that this is nothing but what? Laplace transform of e to the a t. You just check e to the power a t Laplace transform. How we are going to write? E to the a t Laplace transform is nothing but e to the a t into e to the minus st dt. So same thing it is there, सेम चीज यहाँ पे भी है, e to the minus a t into e to the a t dt. That means Laplace transform of e to the a t. So this one is nothing but Laplace transform of e to the minus a t. Okay, so Laplace transform of e to the a t we found how much? 1 by s minus a. Laplace transform of e to the a t we found 1 by s minus a. So there directly I can put the value 1 by s minus a minus here e to the power minus at. That means 1 by minus of minus a. So 1 by 2 is there, 1 by s minus a minus 1 by s plus a. So if I am going to add, then I can get a by a square plus a square. See, s minus a, s plus a square minus a square obviously. So Laplace transform of sin st, we found a by a square minus a square. Similarly, inverse Laplace transform of a by a square minus a square will be equal to sin h a t. Have to remember both. Okay. If this question asked in your exam, it will be minimum 2 to 3 mark. Okay. Next, cos ht. Similar manner we are going to evaluate. For cos ht, it will be written as e to the power at plus e to the power minus a plus. For the sine, it will be minus. You have to remember. For cos, it will be plus. Plus e to the minus at by 2. Taken outside 1 by 2. So you just write e to the minus st, e to the at plus e to the minus st into e to the minus at dt. So we can get the two integrals. So this will be e to the power at is there, means Laplace transform of e to the at. This will be Laplace transform of e to the minus at, right? So Laplace transform of at will be equal to 1 by s minus a plus this will be 1 by minus of minus a, right? So what will the difference? Only difference is here minus and here it is plus. So if I am going to add, then this will be numerator will be 2s and denominator obviously a square minus a square. So 2 got cancelled and we found Laplace transform of cos ht equal to s by a square minus a square. Okay. So uh, inverse Laplace transform of s by a square minus a square will be equal to cos h a t. You have to remember, just mag up these two for your exam point of view. Next, we are going to go for the next function, that is your e to the power at sine omega t. So similar manner we have to write e to the power at sine omega t. Laplace transform means e to the minus st and this function dt. Sin omega t here written as e to the I omega t minus e to the minus I omega t by 2y, that we know dt. Then here you can see we are going to get the two integrals. Here e to the minus st is there, e to the at multiplied with this one, it will be e to the a plus I omega t dt, and e to the at multiplied with this one, e to the a minus I omega t dt obviously. So here you can see that e to the minus st is there. So this function is there. So e to the st and this function, that means this integral is telling that ये जो इंटीग्रल है ये बोल रहा है कि this is the Laplace transform of this function. So we have to write just Laplace transform of this function e to the a plus I omega t and minus Laplace transform this function a minus I omega into t plus here minus. Okay. You can see that this is in the, it is like of, it is look like e to the power at. Okay, here instead of a plus I omega is there. So we know that Laplace transform of e to the power at, Laplace transform of e to the power at is nothing but 1 by s minus a. So here instead of a plus I omega is there. So what we have to write, 1 by s minus this one, a plus I omega minus, likewise for this we have to write 1 by s minus this one, a minus I omega, because here I written it because as Laplace transform of e to the at equal to 1 by s minus a. You just subtract these two terms, we can found 1 by 2y is already there. So numerator will be e2y omega and numerator here you can see that this is s plus, okay, sorry, s minus, it was correct, so here denominator in which way you have to write, see, s minus a, this will be minus I omega, s minus a, this will plus I omega. So here you can see s minus a plus I omega, s minus a minus I omega, and this is plus omega. The a minus b, a plus b format is there. So this will be s minus a square minus I omega whole square. So this will be minus omega square, minus is already there, plus. So Laplace transform of e to the at sin omega t is your the 2y got cancelled, omega by s minus a whole square plus omega square, and inverse Laplace transform of this one, omega by s minus a whole square plus omega square will be equal to this much, that is your e to the at into sin omega t. Okay, you have to remember both. Now we are going to consider e to the at cos omega t. Here instead of cos omega t, same procedure you have to follow. Same procedure. E, we have to write e to the minus st, e to the at into cos omega t. Instead of cos omega t, we can write this one, e to the power I omega t plus e to the minus I omega t by 2. Same procedure you have to follow, and you can get Laplace transform of e to the at cos omega t will be equal to s minus a by s minus a whole square plus omega square. Okay, and obviously inverse Laplace transform of this one, this one will be equal to e to the at into cos omega t. Here you can see that suppose instead of a, c will be there, omega b will be there. What we have to write? S minus a means c, s minus c by s minus c whole square plus, here instead of omega b is there, plus b square. Okay, suppose instead of c, minus c is there, so what it will be? So minus of minus c means s plus c, so this will be s plus c whole square plus b square. Likewise you have to uh, solve if you are going to uh, face this kind of numericals. Okay, next we are going to go for this one was 11, right? Next 12, 12 number function t into e to the power a t. See, always in this format you have to write e to the minus st into t into e to the at dt. Okay, suppose this question asked for 3 marks or 2 marks, you have to do these steps. Okay, so 0 to infinity t into e to the power, see here this will be what? This will be, here you can see minus s plus a. If I will take minus common, this will be s minus a into t into dt. Okay, so you just do the by parts. So as it is arithmetic, the first function, integration of this one e to the minus s minus a t by minus s minus a minus 0 to infinity, derivative of this function t is 1, and integration of this one will be this one, and again integration 0 to infinity dt. If I will put infinite for this upper limit, this value will be 0, then minus, if I will put 0 also it will be 0, so this entire value will be 0. Now we are going to consider this one, here minus minus plus, and e to the minus of s minus a into t by s minus a into dt. Integration means what will be? It will be e to the minus s minus a t, again divided by minus s minus a, minus s minus a already there, so minus s minus a whole square. Just put the limit. If I will put the limit, the first term will be 0, second term will be, here I substituted. See, minus 1 by s minus a square taken outside, 0 to infinity. So first you put infinite, the value will be 0, minus 0 if I am going to put instead of t, it were 0 means 1. So minus minus plus, we found Laplace transform of t into e to the at will be equal to plus 1 by s minus a whole square. Okay, here you can see that if suppose instead of a, minus b is there, so it is minus b is there, so what we have to what the result will be? 1 by minus of a minus b square, that means 1 by s plus b square will be the answer. Okay, suppose minus a, suppose will be there instead of a minus a, so it will be 1 by s plus a whole square. So you just remember this expression that t into e to the at will be 1 by s minus a whole square, and obviously inverse Laplace transform of 1 by s minus a whole square will be equal to uh, t into e to the power a t, right? Okay. Next, we are going to go for the 13 number expression. Before that, here I am going to uh, prove the fast shifting theorem or fast translation property. Why I am going to do so, you just watch. Suppose Laplace transform of ft, if we are going to consider, the value is how much? In the form of f of s. If Laplace transform of e to the power at into f of t, the value will be f of s minus a. If e to the power at is multiplied, no, then the value will be whatever the f of s value for f of t, there instead of s we have, you have to write just s minus a. You just write s minus a. Here is the proof that Laplace transform of e to the at f t will be written as this one. So e to the minus s t and a t is there. So e to the minus s minus a t f t we can write, and s minus a is considered as r. So e to the minus r t into f of t dt. So as e to the minus r t f of t dt, so we can write f of r. If it is s, it will be written as s. If it is r, then f of capital F of r. F of r we considered s minus a, s minus a. Okay. Here I explain Laplace transform of t equal to e to the minus st ft dt means f of s. If it will be r, then it will be f of r. So here we found that if e to the power at is multiplied with a function, then whatever the Laplace transform of that function, in that Laplace transform only instead of s we have to consider s minus a. Here we can see that t into e to the power at. What we found? We found that 1 by s plus a square. So here I can consider that this is in the form of what? E to the power at into t. Okay. Already we have been discussed t to the power n. Here you can see t to the power n. T to the power n is your n factorial by s plus s to the power n plus 1. So if we are going to consider only t, then the value will be Laplace transform of Laplace transform. Here it is. I don't. Here Laplace transform of t is how much? 1 by a square. Okay, 1 by a square is the Laplace transform of t. So if t into e to the power at is there, according to fast shifting theorem, what we have to write? Here 1 by s is there. Instead of s, we have to write s minus a. So 1 by s minus a square will be the answer. And this is the value we found. This one here, 1 by s minus a square. Okay, here 1 by a square only for the t. If I will be multiplied e to the power at dt likewise. So according to fast shifting theorem, instead of s it will be s minus a whole square, right? Likewise, next your 13th function is your e to the at sin ht. So what will the value? Whatever the sin hbt Laplace transform we already evaluated. In that, wherever s we have, there we have to put s minus a. Here you can see Laplace transform s sin hat. Here sin hbt is there instead of sin at. Sin hbt is there, same thing. So what will be the answer? B by a square minus b square for this one. For this one, sin 80 sin 80 sin hbt. See, for sin hbt, what will be the Laplace transform? Here I am going to consider, then a by, we can get a by a square plus a square. Sorry, here b means b by a square plus b square. A square plus b square. Sorry, b by a square plus b square. Okay. So if we are going to multiply e to the 80 according to fast shifting theorem, this value, the answer will be b by s minus a whole square plus b square. The answer will be this much. So if we are going to derive the Laplace transform of e to the 80 into sin hbt, also we can found same thing. Okay. Also you can get the same thing. So how we can do this? Here e to the power 80 Laplace transform of this one, e to the power 80 sin hbt will be written as e to the power 80. Already e to the sin st will be there. 0 to infinity e to the minus st into e to the power 80 into sin hbt dt. 0 to infinity e to the minus sin minus e to the minus st and here sin hbt will be written as this one, e to the bt minus e to the minus bt by 2 dt. So obviously two integral we can found, and this one is nothing but Laplace transform of e to the a plus b into t. This one will be a to the minus a e to the minus a e to the a minus b t, and obviously e to the at. E to the at means 1 by s minus a. So here a is nothing but a plus b. So 1 by s minus a plus b minus 1 by s minus a minus b. So here s minus a minus b minus 1 by s minus a plus b. So here consider this one is your a, this one is your b. So a minus b, a plus b format is there. So s minus a whole square minus b square. Numerator will be 2b, 2 got cancelled. We found b by s minus a whole square minus b square. Same whatever we discussed, that using first shifting theorem. Okay. Similarly, e to the power 8 cos ht. What will the value? Cos hbt. So cos hbt, the value of the Laplace transform of cos hbt. See here, cos hat is nothing but s by a square minus a square. So cos hbt will be s by a square minus b square, right? So e to the 80 is there, means instead of s we have to write s minus a. So value will be s minus a, instead of s minus a square minus b square. Similarly you have to do, if you are want to derive, suppose this question asked in your exam, so you have to derive means here sin hb written as e to the bt minus e to the minus bt. For cos hbt will be e to the power bt plus e to the power minus bt. You have to write and derive same manner, and you can get this answer. Okay. And remember one thing, fast shifting theorem here I discussed. Okay. And this theorem always you can found 1 or 2 mark in your exam. So this is only 2 to 3 steps, but oftenly 90% chances that you can get this question in this your uh, in your exam. Okay. Now we are going to go for the second one, 15th one. Okay. 15th one is your t sin 80. T sin 80. Okay. So how we are going to evaluate? Laplace transform of f of t will be t sin 80, will be written as e to the minus st t sin 80 dt. Instead of sin 80 we can write e to the power I 80 minus e to the minus I 80 by 2i. 2i taken outside, two integrals we can found, and this one is nothing but Laplace transform of t into e to the it. This one is your Laplace transform of t into e to the minus it. Here I written t e to the power, see, t into e to the power at is nothing but, see, in this is shifting theorem, only t value is 1 by s. Okay, 1 by s square. So if e to the 80 will be multiplied with t, then it will 1 by s minus a square. Instead of s we have to write s minus a. And here one thing I am going to tell to you, suppose t to t square is there, suppose function like this e to the power 80 t square is there. So what will the Laplace transform? See, first we have to consider Laplace transform t to the power 2. T to the 2 means t to the power n factorial, that will be 2 factorial by s to the power 2 plus 1 3. So this will be the Laplace transform of only t square. So if it is written as given that e to the power 80, suppose हमको दिया गया है e to the power 80 multiplied with t square. T square का Laplace transform इतना है, तो e to the power 80 into this one will be, instead of s we have to write s minus a. So 2 factorial by s minus a whole cube will be the Laplace transform of this one. Okay. Okay. Now here e to the power 80 t is there. So for t will be 1 by s square. So e to the power 80, here a is I a. Okay. Here a is I a. So s minus I a square minus is there 1 by s minus of minus I a. So plus I a square. Okay. So you just subtract these two terms. We can found in the numerator 4s into ia divided by, here you can found, see, a minus b whole square into a plus b whole square is your a square minus b square whole square, that we know. So here you can see that I got cancelled, we can found 2 cancel out, we can get 2s whole divided by a square is the a square, I square value is -1, so plus a square whole square, right? Okay. Now 16th number function ft equal to t into cos 80. Similar manner you have to derive whatever we discussed for sin 80. Here's cos 80. Okay, but here for the sine we considered e to the I80 minus e to the minus a I80 by 2i. For cos you have to consider e to the I80 plus e to the minus I80 by 2. Similar manner if you are going to derive, then you can get Laplace transform of t into cos 80 will be a square minus a square by a square plus a square whole square. So here you have to also remember that inverse Laplace transform of this one a square minus a square plus a square whole square will be equal to this much. Inverse Laplace transform of this one equal to this much. Here also inverse Laplace transform of b by a square minus a square whole square minus b square equal to this much. Okay, so all the Laplace transform and corresponding inverse Laplace transform I am going to write in a single page, and I'm going to do a small video which will help you to remember all at a time. Okay, so I suggest you just remember the Laplace transform value of all these functions, all these 16 functions. Whatever the value, automatically it's reverse is your function. Laplace inverse Laplace transform of this one will be this one. Likewise, inverse Laplace transform of this one will be this one, like that. Okay, if 1 mark question asked, you have to write the answer. If 2 to 3 mark will be asked in your exam, you have to just derive whatever we have been derived in this video. Thank you so much for watching this video. Thank you.